So the motor can operate in either direction. Right? The kind of motor that has field lines going in opposite directions, and so it can operate in either direction. You guys remember the growler a little bit about the growler? The purpose of the growler test is to determine the presence of. That's how we determine and find a shorted armature. The growler does. A little will growl at you, right? It's called that. So a growler is going to test, and you're going to find for a shorted armature for a growler. If a generator is equipped with a vibrator type voltage regulator, the actual time the voltage regulator points remain open is dependent upon the load carried by the generator. So the time in which that will be open is dependent upon the load. The type of electrical wire terminals used for most aircraft applications, in addition to providing good current carrying capability, are designed primarily to prevent circuit failure due to the terminal disconnection. That's the main reason you see those. It's really what they're for, so make sure that you have a good place there to get to. The commutator of a generator. Everybody remember this one a little bit? What does it do? What does it actually do? It changes alternating current produced in the armature into direct current as it is taken from the armature itself. Now, of course, this is on a DC generator. Remember, on the AC generator, we use slip rings, right? What does the rectifier do? Everybody get this one.
What is what?
The rectifier do?
Use AC to DC.
AC to DC, yeah. Rectification. What type of instrument is used for measuring very high values of resistance? It's actually kind of almost a dangerous instrument. Actually, has a warning on it when you use it. The one I ever used, I had to hand crank it. Megameter. Measuring very high values of resistance. Now, the one place, and the only time I've ever had to use one, a couple of times, is when you put on and change the base of a static wave. One time I ever had to use that. Now when a diode is checked for an open circuit, remember I was about troubleshooting a diode? We're going to check it for an open circuit. It should be, you got to disconnect it from the circuit, right? You got to take it from the circuit to do so. What factors must be taken into consideration when determining the wire size to be used for aircraft insulation? Remember that chart we had about the gauge, right? Think about all the various factors there that came into play. So the mechanical strength of it would be one of them, right? It would be, which is basically the material. Ease of insulation. I'm sorry, we have what happened here? Hold on a minute.
Is this like a multiple answer?
No, it gave a weird, somebody did this incorrectly.
Is it
Hang on,
possible to put
sorry.
on the board?
Oh my goodness. I think they got two questions mixed up here, is what they did. They did. Okay. Let's take this here. Okay, let's try this again. Which of the following factors must be taken into consideration when determining the wire size to be used in the insulation? Again, we're going back to that chart that we had, right? Yeah. So reliable power loss, right? Remember that? That was one of the problems we had to look at. Right? The voltage drop. Permissible voltage drop. The current carrying capability of the conductor. And the load. Remember, the load is a continuous or is it intermittent? So we have a continuous intermittent load. My current carrying capability of the conductor itself.
Can you put this on the board? Is that possible?
I can't, not really. I wish I could. I don't think so. It's kind of a strange environment. Somebody took something and did something with it, so I understand. I can say it, so. But yeah, so you're looking at allowable power loss, which is the, but you have that on there. And I can put the card, so I can find that chart again. Then we have voltage drop, current carrying capability, and it's a continuous load or intermittent load. Now, when selecting hardware for attaching bonding connectors to the aircraft structure, what should be considered? The mechanical strength of it, right? Ease of installation, the amount of current to be carried. Now, most of the time, and then what they're referring to in that, generally speaking, this would be for more of a general type aircraft. If you're dealing with pretty much anything but that world, that small little world, you're going to go to an IPC. It's going to tell you exactly what to use. So, just keep that in mind. How should splices be arranged if you have several that are located electrical wire bundle? You want to stagger them, right? You want to stagger them along the length of the bundle. Remember that one picture that had them staggered like that? You want, obviously, you don't want them all to be in one place, so you stagger those. Otherwise, you get the bundle to be too large. When improved splices may be used to repair harnesses and install in the wiring, the maximum number of splices permitted in any one section may be
One.
yeah, but it's between it's one. Another way to put that too, that you might see that worded, might be, for example, between any two connectors, just to verify it. So you have it between two connectors, you can only have one splice. And there are things that cannot be spliced. Any FQIS stuff cannot be spliced. Any power feeder cable cannot be spliced. Certain coaxial antennas cannot be spliced. So. Let's see. Aircraft fuse capacity is rated in, as is pretty much any other type of current limiting thing.
Aircraft what?
Amperage, right?
Yeah, aircraft fuse capacity is rated in amperage. It's correct. If one switch is used to control all navigation lights, the lights are most likely connected parallel to each other in series with the switch. Remember our one little troubleshooting guide we had up there? From here to here, and then to identify, kind of chasing it back. Parallel to each other and in series to the switch. Aircraft electrical junction boxes located in the fire zone are usually constructed of stainless steel. Yeah, pretty much exclusively stainless steel. And remember on those boxes, you want them to be thick enough too where they're not going to have any oil candy, right? To minimize radio interference, a capacitor will largely eliminate and provide a steady direct current. The capacitor is connected to the generator in. It's going to be parallel to the generator. Okay. The capacitor is going to be parallel to the generator. Primary consideration when selecting electrical cable size is what? Current carrying capability and allowable voltage drop. If you're looking at the two main things, that would be it right there. Your current carrying capability and the allowable voltage drop.
And the what?
Voltage drop, allowable voltage drop. Now Navigation lights on some aircraft consist of a single circuit controlled by a single switch, which has an on position and an off position. No additional positions possible. This type of switch is referred to as a single pole, single throw. That's it. Yeah, which also you might see this used, or you might see it as a two-position switch. So you might see that on there. Okay. So single pole, single throw, two-position switch. We're just looking for that. Electrical circuits are protected for overheating by means of, and we know that we have a lot of circuit, as far as circuit breakers, but we're looking for their fuses, by means of fuses, right? Okay, I'll give you some statements here. All electrical cables splices should be covered with soft insulating tubing, spaghetti with mechanical protection against external abrasions. That's just her and dust tearing me up. Is that a true statement?
Can you say it again?
The electrical cable splices should be covered with soft insulation tubing. That's the spaghetti they call it. For mechanical protection against external abrasion.
True.
No. That's, only in certain areas. Environmental areas or, yeah. That'd be a heat shrink. And that's it, call that as well. Here's another statement. When attaching a terminal to the end of the electrical cable, it should be determined that the strength of the cable to terminal joint is at least twice the tensile strength of the cable. That is not a true statement. Okay? You're not going to worry about the tensile strength. You worry about the materials that they are. And how about this one? When attaching a terminal to the end of an electrical cable, it should be determined that the strength of the cable to terminal joint is at least equal to the tensile strength of the cable itself. That would be accurate. That is a true statement. It needs to be equal to the tensile strength of the cable itself. So sometimes it's very specific about part numbers. I should give you a particular splice it needs to be, or whatever it would be. Right? That's why. It's metal, which also subsequently is strengthened as well. It's kind of like if you think about a weld, right? You want it to be as strong as piece. So it's that splice properly with the right pressure and everything. That should hold it. Bonding connections should be tested for. When I change my bonding strap, I put it back on. What am I going to test it for? Resistance value, exactly right. Yeah. What kind of switch should be installed in a single wire circuit? It requires a switch to be manually held in the on position. That'd be a single pole, single throw, two positions normally open switch. Here's the thing, because it's held in the on position. Manually held in the on position. Right.
Would that be normally closed?
That'd be normally open.
Oh, right.
Two position normally open. Circuit breaker It's installed on an aircraft electrical system primarily to protect the circuit. And you want it to be as close as to the source as possible, right? Circuits to protect the circuit located as closest to the source as possible. Everybody remember using a voltmeter, how we connect it? I'm using a voltmeter, how do I connect it?
And it's here.
Parallel. Current series. How does the routing of a coaxial cable differ from the routing of electrical wiring? One thing in a coax cable, besides of our radius, if you remember that, is that coax cables are routed as directly as possible. You want to make sure that's short as it can be. If it's necessary to use an electrical connector where it may be exposed to moisture, the mechanic should use a moisture-proof tape or really use the wrap. That's what you would use there. That's where you would apply it. But they're looking for special moisture-proof tape, and that is an actual FAA question. So, there are three kinds of protection devices most commonly used in aircraft circuits. They are. You guys remember what we have? First up, what would be one of the first ones?
Circuit breakers.
The circuit breaker. What else? Use it, and then what else? A current limiter.
Current.
So we have a fuse, a circuit breaker, and a current limiter. So your through circuit protection devices. If a wire is installed so that it comes in contact with some moving parts, what protection should be given to the wire?
It should run through a conduit.
That's right. Exactly right. You want to make sure the wire runs through a conduit. AWG, right? You've seen that AWG, American Wire Gauge, right? American Wire Gauge system of numbers uses a designated electrical wire size. The number assigned to the size is related to its
Diameter, right?
cross-sectional area. Relate to the cross-sectional area. What is the purpose of selecting a derated switch for known continuous load current application? And you remember how the aircraft switches are rated, right? And so what we're talking about there is we're going to select that derated switch. And why would we do that? To obtain reasonable switch efficiency and service life. In other words, it's like you're increasing this margin. That's why the switches are derated. Make sure that it's going to have a longer service life. What is the advantage of a circuit breaker compared to a fuse? Now think about this one, right?
You can reuse the circuit breaker, or you can like push
Yeah,
it
you
back
can
in.
reset the circuit breaker where a fuse has to be replaced.
There you go. Yeah, resettable and reusable. The circuit breaker is resettable and reusable. A lot of things go to cost too, it's boy. When electrical cables must pass through holes in bulkheads, ribs, firewalls, the wire should be protected from chafing by what? Do you remember our picture? Grommet. That's it. Grommet. Make sure you have a grommet around that. And they have the grommets. Some places you can install a centipede. They call them centipedes. Wrapping south their channel. An aircraft electrical system automatic reset circuit breakers should not be used as a circuit protection device. On an aircraft, we always use what? Trip-free, that's right, and that would not be that. So an aircraft vertical system, automatic reset circuit breakers should not be used as protection devices. A certain switch described as a single pole double throw switch, the SPDT. The throw of the switch indicates the number of. So kind of think of it a little bit. The pole of the throw. So the number of the throw switch indicates what? The number of what? Basically, the number of circuits a pole can complete through the switch.
The number of holes?
Number of
Right.
circuits.
If you have a certain switch that's a single pole double throw, right? The throw of the switch indicates the number of circuits each pole can complete through the switch. When considering an alteration, the criteria upon which the selection of electrical cable size should be based are what? Current carrying capability and the allowable voltage drop. It's almost a question you're going to see a couple of times. Looks like. So the current carrying capability and allowable voltage drop. What is the important factor when selecting aircraft fuses? I would say this would be the same thing for anything, right? The capacity matches the needs of the circuit. Now sometimes, well, and it is actually controlled by this gauge wire that you have. In a home, you have a 20-amp breaker and it better have a 12 gauge wire on it. 15 can run a 14, but yeah. 12 gauge runs for a 20. If you have a 30, it has to be 10 gauge. Going to a 50, it has to be 8 gauge. Changes. The circuit breaker in an instrument lighting system protects the what? Wire from getting too much current. No matter where that circuit breaker is, that's what a circuit breaker is doing. Protecting from getting too much current. That's only too much heat. One advantage of using an AC electrical power in aircraft is, I want you guys to think about what was the main advantage of AC. What are the main advantages of AC was what? That's it. Exactly right. Did step up and step down, the ability to step it up and step it down. So, why are the iron core of most induction coils laminated? So, when the iron cores are through there and they laminate those to reduce. It's funny because in the units where you do the testing, you want this. It's also a test we do. When that in application, you don't want it. Eddy current. It reduces the eddy current. So you put that laminate in there. Operation and battery furnished DC electrical power for standby emergency use. Aircraft of this type that operate no DC generators, the batteries are kept charged by rectifiers. These aircraft's AC generators as a source of power. So the rectifiers themselves actually charge the battery, right? One thing that keeps your DC battery charged.
Okay.
Think about that. That rectifier. Remember, thinking about what it does. Voltage and an AC transformer secondary that contains twice as many loops as the primary will be. Remember, think about our primary and secondary. Think about the relationship of what we have there to, remember, voltage and amps, right? So what happens as we step it up, we have a step up, so we have more coils in the second one than the first one, right? We're going to step up that voltage, but what else are we going to be doing?
Stepping down current.
Stepping down the current. So greater and the amperage less than the primary. Right, so that's what's going to happen there. So the voltage is going to be greater and the amperage less than the primary. So that would be the description of a step-up transformer, right? If the positive field lead between a generator and the generator control panel breaks and is shorted while the engine is running, a voltmeter connected to generator output would indicate you can almost, if you draw it out and kind of understand what you're looking at there, what it would see then, a lot of people want to put 0, that wouldn't be the right answer. It would see the residual voltage, which might be, fairly low, actually. But it would see residual voltage. Actually, I had to do this one time. What method is used for restoring generator field residual magnetism? So if you have a generator that's pretty old, whatever that can happen, and remember how it gets excited? It already has that in it. So we turn it and it starts turning. It produces that because of our flux. What happens, right? However, that's based on having that residual there. Okay, and if it's set for too long, then whatever it could be that you don't have that residual, you even get it excited. So then you have to flash the field. You flash it, a lot of that's going to excite it. So effectively, that's what that does. When you flash the field, you're exciting it, so now it'll go. So it's flash the field. Method used for restoring generator field residual magnetism. When using an ohmmeter to check the continuity of a generator field coil, the coil should show very low resistance as if it was a series field coil. It should show very low resistance. And and I guess you'd use that for troubleshooting. So, and remember the continuity as well. The strength of a core of an electromagnet depends on the material from which it is constructed and which of the following. Well, remember some of the things that help with that, or that control that? It's going to be the number of turns of wire in the coil and the amount of current passing through the coil. So the number of turns that were in there and then the amount of current passing through it. Those are the two factors that are going to help with that electromagnet. A voltage regulator controls generator voltage by changing let's think about what it's doing there actually effectively. And of course this happens really quick doing it, but so what is it really doing? What is any regulator effectively doing? How does it control that and keep it there? Again, I'm talking voltage regulators. If you have like a generator control unit, like the large aircraft have, because an IDG keeps a certain RPM. That's how it controls the frequency and everything else. All those parameters are part of your GCU. But in this case, what we're talking about is an actual voltage regulator, and it regulates the what? The resistance to the generator field circuit. Basically, how much it gives back, which is going to affect its output. If you have an overvoltage control, automatically protects the generator system when it says the voltage is present by what? it's gonna open the shunt. It's gonna open the shunt field and basically more or less dump it off. So it's gonna open the shunt field circuit. When a DC generator is operated in parallel to supply power for a single load, their controls include an equalizer circuit to assure that all generators share the load equally. The equalizer circuit operates by increasing the output of the low generator and decreasing the output of the high generator until they're equal. Very simple, right? It's going to sit there and adjust it continually to maintain that equalization. In these systems, some of these systems would have an extra unit in there, and that's literally what it does. It's almost like a generator control unit.
So it's increase and.
And it's going to increase the one that's low and decrease the one that's high. And this goes back and forth, back and forth, back and forth, trying to maintain that equilibrium in there. What is the maximum number, the maximum amount of time it certainly can be in operation and still be an intermediate duty circuit? Now remember, as far as definition, we're talking about on that, when you think about that chart, for example, you know, what's continuous, what's intermittent. And that also has to do with a lot of things on the aircraft that are there. For example, a starter. The starter would fall into that. You know, it's not meant to be. It has an intermittent load. The gear motor, same thing. It's an intermittent load. And so it's 2 minutes. 2 minutes. Anything over 2 minutes is considered, would be considered a continuous. The most common method of regulating the voltage output of a compound DC generator is to vary the current flowing through the shunt field coils. That's the actual best way to do it. Vary the current through. Remember, your shunt field coils is what's going to actually control that. So if you change what's going to that, that's how you're going to control your. If any one generator in a 24-volt DC system shows low voltage, the most likely cause is, most likely it's going to be your voltage regulator, a non-adjustment voltage regulator. How can we change the direction of rotation of a DC motor? Reverse the electrical connections to either the field or armature windings. Yeah, so you reverse either one of those, you effectively do that. Now, some motors that have that set up are done through switching, and that's what they're doing, but they're simply doing it through a switch. Aircraft which operate only AC generators attempt as a primary source of electrical power in order to provide current suitable for battery charging through the use of in this case, we're talking about the same thing. So our battery charger is going to what? Remember before we talked about it another way? Here we still got pretty much the same question, worded a little different. But it's going to be a transformer. It's going to be a transformer rectifier. It'd be a step-down transformer, yeah. Here's what I mentioned. I remember talking about this a little bit. You guys remember. During inspection of the collision light, installation for condition, and proper operation, it should be determined that a collision light always needs to operate independently and separately of position lights. Remember that the position lights, see a lot of time that's how that was, but now we know that they're separated, and that's a actual FAR. They're maintained that way. The reason is you do certain things, for example, on the ground, if you do an engine run, you turn that light on, right? If you're doing pressurization, you turn that light on. There's other maintenance actions that enforce that light. Yeah, for safety reasons, what they are. So You wouldn't want that to be connected with that. So, yeah, the anti-collision light can be operated independently of the position lights. Major adjustments on equipment such as regulators, connectors, and inverters are tests accomplished outside the airplane on test benches with necessary instrument and equipment. Adjustment procedures should be outlined by. So this is where you can talk about overhaul manuals or things of that nature, but what they're looking for is the equipment manufacturer. Basically go back to their, because you're talking, basically when you're talking about that, you're talking about a bench test. That's what that's really referring to. That's what you're doing. A battery generator system provides direct current on installations requiring alternating current from the battery generator system. It is necessary to have what? I have a battery generating system and I need AC current. What do I have to have? So remember, it's an inverter, right? A rectifier is going to take your AC to DC. And so in the aircraft, remember they're going to call it a static inverter. But that's what it's doing, it's taking your DC to AC. What is the advantage of a current limiter? And we're talking about, we say current limiter over a circuit breaker. Okay. You remember we showed that one fuse to you? I showed that fuse that did the same thing. Talked about it. Well, current limiter does the same thing effectively. And that is, it'll take the overload for a short period. That's the advantage. What's the advantage of a current limiter? It takes the overload for a short period. In an AC circuit with no phase lead or lag, which is true. Now think about that. You remember, go back, remember Eli the Iceman? You guys remember Eli the Iceman a little bit? That's what we're going to talk about there. So looking at that, if I have an AC circuit with no lead or lag, real power is going to equal apparent power. They're going to be one and the same. Real power and apparent power are going to be one and the same. Okay. How are our generators rated? Amps and voltage. Really has to do with how many amps it can put out. Yes, you'll see a generator with watts. That's true. And when you see them, you'll think that, but unless you're actually after the amperage. It really is about how many amps can I push through it. So yeah, it's amps and voltage, the rated voltage. How is a shunt wound DC generator connected? The key with that is shunt wound. Both fields are shunted across the armature. And a shunt wound, both fields are going to be shunted across the armature. What is the frequency of an alternator dependent upon? We talked about it just a minute ago. So what is the frequency of the alternator dependent upon? Remember I said that in order to maintain it, we maintain the RPM, exactly. That's the answer. What is the frequency dependent upon? The RPM. Which is how an IDG works. We're going to drive our CST controls the generator in the same fashion. The generator rating is usually found stamped on the generator. Residual voltage is a result of magnetism in the. Now we went over this for just a little bit. It's going to be the filled shoes. Yeah, they normally have it in there. They're normally excited. It should be in the field shoes. In troubleshooting an electrical circuit, if an ohm meter is properly connected across the circuit components, and some value of resistance is read, what does that mean? It means that the component has continuity and it's not open. It has continuity. If you had a red across there, we know we have continuity, right? CSD driven generators are usually cooled by normally they have ram air and they normally have an internal fan. CSD units drive a generator through the use of, what they do is they control by a hydraulic pump and a hydraulic motor. That's how they control the speed. It's either directly proportional. The pump will keep up the other and keeps that speed.
Is that what you?
How CSD works? Yeah. Integrated drive units, IDGs, employ the type of high output AC generator that utilizes a brushless system to produce current. Yeah, brushless system to produce current. Now, do you remember our relationship between copper and aluminum wire when we're talking about the gauge of the wire? We normally talk about if I had, yeah, well, it's you go to aluminum, we have to increase the gauge, right? We have to go up another, and so that's the actual true question at hand. But in this here, what we're talking about is what happens when we step that down. So if I have an aluminum, let's see here, a 6 gauge aluminum, what would my copper be? Now think about that. If we had copper, remember we go up the gauge. So if I have aluminum, and my aluminum is 6, right? Yeah, 6. What would my copper be? Be 8, that's right. It would be 8. 8 would be the copper. When necessary during operation, CSD disconnect is usually accomplished by, and this is actually a required check on a return to service or a heavy check. You have to go do that. In the flight deck, you have the CSD disconnects. They have to manually be reset, so we have to
What
wait.
was the question?
It's when necessary during operation, CSD disconnect is usually accomplished by a switch in the cockpit switch. A CSD unit that is disconnected in flight due to malfunction, such as an overtemperature, may be reconnected only on the ground by maintenance personnel. Only on the ground by maintenance personnel. Once you've done that, there is no way in flight to reconnect that CSD or IDG. Oil canning on the sides of aluminum and steel junction boxes is considered to be what? Now let's think about it. If I have that oil canning, everybody knows what oil canning is? The metal pencil actually moves a little bit, flexes, right? It's oil canning. That's why you can see it in the airplane a little bit even. So what is oil canning? Well, it can cause a short. That's the negative thing about oil canning. If it's not stiff enough or whatever, that can happen, it can cause a short. A short hazard is that what they're looking for that. Wire must be stripped very carefully because, so especially on a lot of, and you're going to find probably 80% of the wire you're going to use is going to be stranded wire. So it's really important. But individual strands can break easily after being nicked, so that's the issue with that. So we want to be real careful doing that. Aluminum wire must be stripped very carefully. An ammeter and a battery charger system is for the purpose of indicating the what? Rate the current can be used and changed to charge the battery. Rate the current can be used to charge the battery. If a generator with what elements any in a generator, what elements any possible sparking to the brush guides caused by the movement of the brushes within the holder. What they're looking for there is the pigtail. The pigtail itself, if not done properly, could do that. Could be a possible spark that come from the pigtail. The brush pigtail is the answer for that one. The purpose of a rectifier in electrical system is to change AC to DC. Exactly right. After an automatic driven, an ADF finder antenna has been installed, the what? Remember, the loop must be calibrated. First thing to do is calibrate that loop. VHF radio signals are commonly used in
You said VHF?
radio signals are used in VORs, navigation, and ATC communication. But they're, like I said, they're getting phased out from the VOR side of it. The purpose of a glide scope system is to assist the pilot in making a correct angle of descent to the runway. Remember, the glide scope's your approach. The purpose of a localizer is to, remember the difference in what each one does. The localizer is going to literally allow you to center that in the runway. That's really what it's for. Align the airplane with the center of the runway. So.
Glide scope is the one where you have the red and green lights?
No. Let's see, anything but the marker beacon.
Yeah.
Oh, here we go. This is good. How many of the operations have installed ELT be verified during an aircraft inspection? By turning the communication receiver to the civil emergency frequency and activating the ELT momentarily at 5 minutes after the hour. It's very important to remember that 5 minutes after the hour. Not 30 minutes after the hour, not 15 minutes after the hour, 5 minutes after the hour.
So you said emergency frequency, 5 minutes.
Yeah.
They also have to notify the control tower.
Only if it's outside of that. If it's 5 minutes after the hour, you're fine. So you know what it is. Or could, I mean, but we did it one time about 30 minutes after the hour, because I gave it once a crew chief, give that to somebody who did it. I said, we're going to do that tomorrow. So just step on the work card. We'll do that tomorrow. So just do this on, this off, and we'll turn it over for that tomorrow. And he went ahead and did it. He said, oh, that's not good. He'll call the tower over there. Let's see. When must an emergency locator transmitter battery be replaced other than reading the replacement date? So obviously, when we're talking about, remember, it has a date on it. It's date important. The ELT battery has that. But what's the other thing that might be important? Well, yeah, so when the transmitter's been on for more than one cumulative hour, then you're pretty much your battery is toast. What is the operating principle of the sensing device used in an autopilot system? Where we at? Yeah, what is the operating principle of the sensing device used in the autopilot system? You remember we had that picture, we saw that piece that looked like it looked like a garden, I think, right? That's what it was doing. It's like a inverter, it picks up all the different directions, right? Relative motion between the gyro and the supporting system. That's what it does. And the relative motion between the gyro and the supporting system. The operating principle of the sensing device for the autopilot. It's a landing configuration. The EGPWS typically monitors the radio, the radar, altimeter, and air data computer, instrument landing systems, and what is the other part that's kind of important? Your landing gear and flap positions. Landing gear and flap positions is very important, right? Where's the gear? Is it up or down? Where are my flaps? Dutch roll, a combination yawing and rolling oscillation that affects many swept-wing aircraft, how do you counteract it? If you get into a Dutch roll, how do you counteract it? Yaw.
Yeah.
Yeah. Yaw dampener system. We'll counter it.
What is Dutch roll?
Dutch roll will be this here. You get into a oscillation. You have porpoising, right? Then you have a Dutch roll. So you watch the airplane literally just chase it around.
My mind is going straight to like barrel roll.
So,
So what was the answer again?
Yeah, dampener.
yeah, the yaw dampening system.
Yawn
The yaw dampening system, when that starts happening, will kick the rudder a little bit. In doing so, it'll take that out. As the aircraft comes back and it'll. One antenna can be used for radio range and standard broadcast bands on light aircraft. Because why? The two ranges are so close together. Because they're so close together. And that also, again, is another one that's the same on the ship as well. You do it the same way also. The DME antenna should be located in a position of the aircraft that will what? Not be blanked by the wing when the aircraft is on its bank. That's why it's going to be. You want it to be forward. Okay, you want that antenna to be installed forward.
You said it was not be what?
So that when the wing won't blanket it. If it was back here toward the wings, if you bank, that would happen each time. You don't want the wings to where that going on. The EOT is normally activated by an inertia switch, right? Inertia switch. Or possibly the water. The equivalent mechanism subjected to a force described intensely by the duration and must be activated when the force is applied parallel to the longitudinal axis of the aircraft. So literally you're going to find it literally down in the middle. That's why it's done that way. Literally you go up there and the max, it's like right above your head, the center of the owl. That's where it is. That's why. Parallel to the longitudinal axis of the aircraft. What will occur if an aircraft attitude or change by the autopilot system in order to correct for an error that involved control surfaces and return to the streamline by the time the aircraft was reached its correct position? Now this sounds all some convoluted bunch of this, that, and the other, but really what we're after there, normal. That's what it should do. We want to take it back and put it normal. When must the radio station license be displayed in the aircraft equipped with a two-way radio? Now, I can tell you that at United, we put it in every airplane anyway. But, what is the answer? When must the radio station license be displayed? When the aircraft is operated outside the U.S. Every one of our airplanes have it anyway. When installing coaxial cable, it should be secured firmly like how long? 2 foot interval, 24 inches, that's right. General purpose of an aircraft transponder is for what? Receive an interrogation signal from the ground station, automatically send a reply back. So see that question a couple different ways, but basically it's interrogating. It's going back and forth. So you know where it is. Radar altimeter determines altitude by transmitting a signal and receiving it back, a reflected signal. It gets a signal is what happens there on your radio altimeter. The preferred location of a VOR antenna on light aircraft is on what? The top of the cable, the apex of V pointing forward. Installing radio equipment is protected from damage due to the joints and vibration by what? Shock mounts. A lot of those there on the right, they only have the shock mounts. I'll give you a couple of statements here. First statement. Use solder to attach bonding jumpers to radio equipment. Is that a true statement?
No.
It is not. Yeah, you would never use solder for that. Statement number 2. Radio equipment is bonded to the aircraft in order to provide a low impedance ground and to minimize radio interference and static electrical charges. And that is a true statement. Exactly a true statement, so bear that in mind. When installing a DME antenna, it should be aligned with the, we said this earlier, right? Where does that DME need to go? That's right. The center line of the aircraft. Part of the ADF system used on the aircraft includes sense and loop antennas. Sense and loop antennas for that. The emergency locator transmitter ELT battery replacement date must be marked on the outside of the transmitter. That's where they can see it really quickly. You want it really simple for them to see it too. So where's the preferred location for an ELT? The tail, yeah. But as far as possible, but forward of the vertical fin. On the aspect out there, it's only the bottom there, where the fin is. That they call that the dorsal fin, right where the dorsal fin is. Where you found the ELT. How may the battery replacement date for an emergency locator transmitter be determined? By observing the battery replacement date marked on the outside of the transmitter. It should be marked on it. In a perfect world, it should be there. Does that always happen? Probably not. So, during the week, we have 3:30, Monday, Tuesday, and Wednesday. So, on Thursday,